Hello friends. In earlier few lectures, we have studied how to operate 1 upon f of d on function capital X by using first three shortcut methods. 1 upon f of d operating on e raised to ax, 1 upon f of d operating on sine of ax or cos of ax, and 1 upon f of d operating on x raised to m. But if right side function is multiplication of two functions, then these methods are not applicable. Then you have to apply next two methods, method number 4 and method number 5. Now to find pi, use shortcut methods 4 and 5. Shortcut method 4 is 1 upon f of d operating on multiplication of two functions e raised to ax into v. It is given by 1 upon f of d operating on e raised to ax into v equal to, now take this exponential function out of 1 upon f of d operator e raised to ax and replace all d by d plus a and operate 1 upon f of d plus a on function v. And method number 5 is 1 upon f of d operating on x into v equal to x in bracket x minus f dash of d upon f of d into again 1 upon f of d operating on v. Now advantage of these two methods is to operate 1 upon f of d on two functions is difficult. Then by using method number 4 or method number 5, we can operate on single function v. But we have to make some changes in that function polynomial f of d. For fourth method, replace d by d plus a and function e raised to ax should be taken out of operator 1 upon f of d. And to operate on x into v, use this fourth method. Now using these two methods, we try to solve some examples. Now take first example, that d square minus 4d plus 4 operating on y equal to e raised to 2x into sine of 2x. Then auxiliary equation is d square minus 4d plus 4 equal to 0. And this is square of d minus 2. So d minus 2 whole square equal to 0 gives two values of d equal to 2 and d equal to 2. These are real and repeated values of d. So using case number 2, CF is given by C1 plus C2x into e raised to 2x. Now Pi is given by Pi equal to 1 upon d square minus 4d plus 4 operating on e raised to 2x into sine of 2x. Now observe this function of x. It is multiplication of two functions and one function is exponential. Then compare with method number 4. And using method number 4, we can operate 1 upon f of d on e raised to ax into v. Now this sine of 2x becomes v. Then take e raised to ax means e raised to 2x out of operator. Replace all d by d plus 2 and operate resulting polynomial on function v, that is sine of 2x. Now taking e raised to 2x out of operator, e raised to 2x into 1 upon this d replaced by d plus 2. So becomes d plus 2 whole square minus 4, this d also replaced by d plus 2 and plus 4 as it is and operating on function v. Then to operate on function v, first simplify that denominator e raised to 2x 1 upon d plus 2 whole square is d square plus 4d plus 4. Multiply this bracket by 4. So minus 4d and minus 8. Last plus 4 as it is operating on sine of 2x. Now this is simplified. D square plus 4d minus 4d gets cancelled. Plus 4 and 8 also gets cancelled. So only 1 upon d square operating on sine of 2x. Now to operate 1 upon d square, d means for operating 1 upon d square on sine, replace d square by minus a square using method number 3, shortcut method number 3. So a equal to 2, a square equal to 4 and minus a square equal to minus 4. So replace d square by minus 4. That gives minus e raised to 2x upon 4 into sine of 2x. This is pi. And finally, solution given by y equal to cf plus pi. Now another example is solve this example now. D square minus 2d plus 4 operating on y equal to e raised to x into cos square x. Then again complementary function is obtained from auxiliary equation. D square minus 2d plus 4 equal to 0 gives d equal to 1 plus or minus I root 3. Now these are complex values of d, alpha equal to 1, beta equal to 3. Then using case number 3, CF is given by CF equal to e raised to x in bracket C1 cos of root 3x plus C2 sin of root 3x. And pi is given by 1 upon d square minus 2d plus 4 operating on right side function e raised to x into cos square x. Now again observe right side function. This is multiplication of two functions and one function is exponential. So method number 4 is applicable. Take e raised to x out of operator. Replace all d by d plus 1. D plus 1 whole square minus 2 times d plus 1 plus 4 and operate on single function v cos square of x. And to operate on cos square replaced by 1 plus cos of 2x upon 2. Then these two can be taken out of operator and simplify d plus 1 whole square minus 2 times d plus 1 plus 4, that is 1 upon d square plus 3 operating on 1 plus cos of 2x. To operate on cosine and 1 is expressed in the form of exponential e raised to 0x, and to operate on cosine replace d square by minus 4, so gives e raised to x upon 2, 1 upon d cube plus 1 operating on 1 separate, and 1 upon d cube plus 1 operating on cos of 2x separate. To operate on 1, replace d by 0. 1 is e raised to 0x, and using method number 4 put d equal to 0 gives 1 by 3. And to operate on cosine replace d square by minus 4, so gives finally e raised to x upon 2 in bracket 1 by 3 minus cos of 2x. This pi, and solution finally is y equal to cf plus pi. Now here also we have applied method number 4. Now next example is d square plus 2d plus 1 operating on y equal to x into cos of x. Auxiliary equation is d square plus 2d plus 1 equal to 0, gives values of d equal to minus 1 and minus 1. Values of d are real and repeated, so use case number 2. C1 plus C2x into e raised to minus x is complementary function. Pi is given by 1 upon d square plus 2d plus 1 operating on right side function x into cos x. Now this is multiplication, and in this multiplication one function is x. Then apply method number 5, x into v, where cos of x becomes v. Using method number 5, x minus f dash of d means derivative of this polynomial 2d plus 2 upon f of d means d square plus 2d plus 1 close bracket into 1 upon again f of d, d square plus 2d plus 1 operating on v cos of x. Then first complete this outside term. Now it is completed by using method number 3, shortcut method number 3, put d square equal to minus 1. So minus 1 plus 1 gets cancelled. Minus 1 plus 1 gets cancelled. So only 1 upon 2d. This bracket remains same. Now 1 upon d operating on cos x is integration of cos x equal to sin x. Now this 1 upon 2 sin x multiplied by this bracket x into sin x upon 2 minus, from this numerator take 2 common, so 2 in bracket d plus 1, and this 2 cancelled with this 2. Then d plus 1 upon d square plus 2d plus 1 operating on sin x. And to operate again on sin, replace d square by minus 1. So minus 1 plus 1 gets cancelled, only 2d. So first term as it is, x sin x upon 2 minus d plus 1 also as it is, and 1 upon 2d operating on sin x. Now operate 1 upon d on sin. 1 upon d means integration. Integration of sin is minus cos. So this is minus cos, and minus cos is operated by d plus 1. So first term as it is, x sin x upon 2 minus, now d operating on minus cos x means derivative of minus cos x is sin x, and 1 operating on minus cos x is minus cos x. So this is pi, and CF plus pi is finally solution. Again, one example can be solved. Now let us solve this example. D cube minus 3d plus 2 operating on y equal to x square into e raised to x. Auxiliary equation is d cube minus 3d plus 2 equal to 0, gives values of d 1 and minus 2. So CF 1, 1 and minus 2. So CF is given by C1 plus C2x e raised to x plus C3 e raised to minus 2x, and pi is given by pi equal to 1 upon d cube minus 3d plus 2 operating on x square into e raised to x, operating on x square into e raised to x. Now again this is multiplication, and one term is e raised to x, so use method number 4. Take exponential term out of operator and replace all d by d plus 1. So e raised to x into 1 upon d plus 1 whole cube minus 3 times d plus 1 plus 2 operating on v is x square. Now this is simplified whole cube of d plus 1 multiplied by 3 to d plus 1 and simplify, gives d cube plus 3d square. So 1 upon d cube plus 3d square operating on x square. To operate on algebraic polynomial now, apply shortcut method number 3. E raised to x as it is, and from denominator take 3d square compulsory common. So 3d square in bracket 1 plus d by 3 operating on x square. Now this 1 plus d by 3 factor taken to numerator becomes raised to minus 1. Keeping 1 upon 3d square as it is, 1 plus d by 3 whole raised to minus 1, and expand by using standard formula 1 plus theta raised to minus 1. So that expansion is 1 minus d by 3 plus d square by 9, and stop expansion at d square because to operate on x square. And then operate now all terms separate on x square. E raised to x as it is, 1 upon 3d square also as it is, 1 operating on x square is x square. D operating on x square means derivative of x square is 2x, so minus 2x by 3, and d square operating on x square means double derivative. Double derivative of x square is 2, so plus 2 by 9. Now finally operate 1 upon d square, and 1 upon d square means double integration of this function. So integrate 2 times all these terms, e raised to x upon 3 as it is, and all terms integrated 2 times. Integration of x square is x cube by 3, and one more integration x is to 4 by 4. Total becomes x is to 4 by 12. Similarly, double integration of 2x by 3 is x cube by 9, and double integration of 2 by 9 is x square by 9. Now this complementary function plus pi will be solution of differential equation. Now you can solve many examples by using method number 4 and 5. If right side function is multiplication of 2 terms, one term is exponential, then apply method number 4. If one term is x, then apply method number 5. Now you can go through solution of this next example. that solution differential equation is d square plus 3d plus 2 operating on y equal to x into sine of 2x. Now CF is obtained as usual, c1 e raised to minus 3x plus c2 minus 2x plus c2 e raised to minus x, and pi given by 1 upon d square plus 3d plus 2 operating on x into sine of 2x. Now use method number 5, x minus f dash of d upon f of d into 1 upon f of d operating on sine x. Now go on simplifying and watch all these steps. Note, to operate on sine, we have to generate d square term. Here d square is obtained by rationalization. Multiply by 3d plus 2 and divide by again 3d plus 2. So gives 9d square minus 4, and then operate by shortcut method number 3. If this is completed, again solve yourself all these steps, and finally give solution of differential equation in this form. So this is simplifying all terms. Calculate carefully, and finally solution given by y equal to cf plus pi. So I have completed two methods now, method number 4 and 5, and to operate on multiplication of two functions, apply method number 4 and method number 5.